Find the equation of the tangent line to the curve y is equal to 4x squared plus 3x minus 1 at a point where x is equal to negative 1. By the way, feel free to pause the video and try this question. In another video, I've said that the first thing that is simple to find here is the y coordinates that's gonna pair with this negative with the x coordinates. So it's gonna be y is equal to, we need to substitute negative 1 to this equation, and we're gonna get 4 into negative 1 squared plus 3 into negative 1 minus 1. If you punch this on a calculator, you're gonna get, let me put this on my calculator, plus 3 into negative 1 minus 1. So I get 0. So the y coordinate is gonna be 0. Therefore, our point is gonna be negative 1 period 0. Now, we need to find the gradient of the tangent. But first, we need to find the equation of the gradient of the curve by the derivatives. So if you differentiate this function, you're gonna get 2 times 4. It's gonna be 2 times 4. It's gonna be 8x. Then if you differentiate 3x, you're gonna get plus 3. This is the equation of the gradient of the curve. So the gradient of the tangent is equal to the gradient of the curve at x is equal to 1, negative 1. So the gradient of the curve, it's 8 into negative 1 plus 3. 8 times negative 1, it's simply negative 8. Negative 8 plus 3, you're gonna get negative 5. So the gradient of the tangent, it's negative 5. Let me put this here. And let me erase everything here to get the gradient, the equation of the tangent. Let me erase everything here. Okay, so we do have a point and the gradient of the tangent. Now, to find the equation of the tangent, we're gonna use this standard form, or let me attach the pen. Gonna use this y minus y1 is equal to gradient of the tangent into x minus x1. So y1 simply 0. Our y coordinate is 0, is equal to the gradient of the tangent. It's negative 5 into x minus, if you put negative 1 in this equation, you're gonna get positive 1. Negative times negative, you're gonna get positive. Y minus 0, it's gonna be y is equal to, if you distribute negative 5 into x plus 1, you're gonna get negative 5x minus 1. Minus 5, I mean. 5 times negative times, let me erase here. Negative 5 times positive 1, you're gonna get negative 5. And this is the equation for the tangent line. Number 3, find the equation of the tangent line to the curve y is equal to 2x cubed minus 5x squared plus 4x minus 2. So first, let us find the y coordinates that gonna pair with x is equals to 3. So it's gonna be y is equals to 2 into 3 cube minus 5 into 3 squared, and then it's gonna be plus 4 into 3 minus 2. If you punch this on a calculator, you're gonna get 2 into 3 cube minus 5 into 3 squared plus 4 into 3 minus 2. You're gonna get 19. So you're gonna get 19. Therefore, the point it's gonna be 3 period 19. 3 period 19. Now we need to find the gradient of the tangent. So you're gonna find the gradient of the tangent by the first derivative of the equation. It's dy dx is equal to 2 times 3. You're gonna get 6 x squared. 2 times negative 5, you're gonna get negative 10x. And then 1 times 4, you're gonna get positive 4. So this is the equation for the gradient of the curve. So x is equal to 3. You're gonna get the gradient of the tangent. So it's gonna be 6 into 3 squared minus 10 into 3 plus 4. So you're gonna get 6 into 3 squared minus 10 into 3 plus 4. You're gonna get 28. 28. Let me erase here. So it's 28. You're gonna get 28. This is the gradient of the tangent. Rx is equal to 3. So now we need to find the equation of the tangent by using this standard form. Y minus y1 is gonna be equal to gradient of the tangent into x minus x1. Let me erase the top part. So it's gonna be y minus the y coordinates of the point is 19 is equal to the gradient of the tangent. It's 28 into x minus x1 is 3. So if you transpose 19 to the other side of the equation, you're gonna get 28 times x, you're gonna get 28x. 28 times negative 3, you're gonna get negative 84. And then if you transpose 19 to the other side of the equation, you're gonna get positive 19. And if you combine like terms, you're gonna get 28x negative 84 plus 19. Gonna get negative 65. So this is the equation of the tangent line at this point. Number 4. Find the equation of the tangent line to the curve y is equal to x squared at a point 2 period 4. Now we are given the point. We need to find the equation of the tangent. So if you do have a point, you're gonna need to find the gradient of the tangent by using the derivatives. So it's gonna be we're gonna differentiate this function. So it's gonna be dy dx is equal to, if you differentiate y is equal to x squared, you're gonna get 2x. This is the gradient of, this is the equation of the gradient of the curve at x at a point 2 period 4. We're gonna get the gradient of the tangent, so it's gonna be 2 into 2. So 2 times 2, you're gonna get 4. Then the gradient of the tangent is simply 4. So we're gonna use this standard form is equal to gradient of the tangent 10 into x minus x1. y1 simply 4 is equal to the gradient of the tangent, it's 4, x minus x1, it's 2. Let me carry on here. If you transpose 4 to the other side of the equation and also distribute by 4 in this equation, you're gonna get 4x minus 8. 4 times negative 2, you're gonna get negative 8 plus 4. It's plus 4. So if you add like term, you're gonna get 4x minus 8 plus 4, you're gonna get negative 4. This is the equation for the tangent line. By the way, for every problem that I'm providing for you, feel free to take a shot and fill a pen. So feel free to pause the video and try number 5. Find the equation of the tangent line to the curve y is equal to 2x squared plus 3x minus 1 if the tangent line is parallel to the line y is equal to 4x plus 5. Now we need to first find the gradient of the tangent line. So remember, if lines are parallel, so then that means their gradients will be equal. For parallel lines, the gradients are equal. For perpendicular lines, their gradients, the products of their gradients will be equal to -1. So in this case, the gradient, or let me adjust here first. So then that means the gradient of the tangent line will be equal to the gradient of this line, and the gradient of the line is equal to positive 4. You always, if you want to find the gradient of the line for any straight line, you will take the coefficient of, you need to first make everything to be in a standard form and then take the coefficient of x. So you're gonna find the gradient of the line. So in this case, the gradient of this line, it's simply 4. Now we need to find the point, because now we do have the gradient of the tangent is equal to 4. We need to find a point where the tangent and the curve touch. So we're gonna find that point by using the derivatives. So if you differentiate this function, you're gonna get 4x plus 3. So 4x plus 3 will be equal to 4, because the gradient of the curve, this is the gradient of the curve and this is the gradient of the tangent, and the gradient of the curve is equal to the gradient of the tangent. Now we need to transpose 3 to the other side of the equation, so we're gonna get 4 minus 3. 4 minus 3, we're gonna get 1, and on our left hand side of the equation we'll be left with 4x. Now we need to divide both sides by 4, and then we're gonna get the x coordinates of 1 all over 4. For the y coordinates, we're gonna substitute x is equal to 1 all over 4 into y, into this curve to get the y coordinates. So it's gonna be y is equal to 2 into 1 all over 4 squared plus 3 into 1 all over 4 minus 1. And the y coordinates we're gonna get, let me punch this on the calculator, squared plus 3 into 1 all over 4 minus 1, and then we're gonna get negative 1 all over 8. Our y coordinate is simply negative 1 all over 8. So therefore our point is 1 all over 4 paired with negative 1 all over 8. Let me erase here. Since we do have a point in the gradient now, we're gonna use the standard form to find the equation of the tangent. It's y minus y1 is equal to gradient of the tangent into x minus x1. y1, it's negative 1 all over 8, and if you replace y1 by negative 1 all over 8, you're gonna get positive 1 all over 8 is equal to the gradient of the tangent. It's 4 times x minus x1. x1 is 1 all over 4. So if you distribute this bracket by 4, you're gonna get 4x. 4 and 4, they will cancel out and they will be left with negative 1. If you transpose 1 all over 8 to the other side of the equation, you're gonna get negative 1 all over 8. And now we need to add the like terms in this equation. So we're gonna get 4x minus 1 minus 1 all over 8. We're gonna get negative 9 all over 8. And this is our final answer. Number 6. Find the equation of the tangent line to the curve f of x is equal to x squared. If the tangent line is perpendicular to the line y is equal to negative 2x plus 5. Now, if two lines are perpendicular to each other, then the product of their gradient is going to be equal to negative 1. The gradient of the line, it's simply negative 2. If you divide both sides by negative 2, you're going to get positive 1 all over 2. So the gradient of the tangent, in this case, it's going to be 1 all over 2. Now, let us work out the point. To find the point, we need to find the gradient of the curve, the equation of the gradient of the curve. So it's going to be 2x. If you differentiate this equation, you're going to get 2x, and it's going to be equal to the gradient of the tangent, which is equal to 1 all over 2. And if you divide both sides by 2, you're going to get x is equal to 1 all over 4. Now, our x coordinate is 1 all over 4. To find the y coordinate, you're going to substitute 1 all over 4 into the original equation to f of x, not the equation of the line, because we want the equation, we want to find the point where this curve and this tangent touch. So you're gonna substitute 1 all over 4 into f of x. So you're gonna get 1 all over 4 all squared. 1 all over 4 all squared, it's gonna be 1 all over 16. Therefore, our point is gonna be 1 all over 4 paired with 1 all over 16. Let me erase everything here. Okay, so we're gonna use this standard form y minus y1 is equal to gradient of the tangent into x minus x1. Now y1 is our y coordinates of the point, which is 1 all over 16 is equal to the gradient of the tangent. It's half x minus x1. x1 is 1 all over 4. So let us transpose 1 all over 16 to the other side of the equation, and we're going to get 1 all over 2x minus 1 all over 2 times 1 all over 4. We're going to get 1 all over 8 minus 1 all over 16. Let us combine the terms. Therefore, we're going to get 1 all over 2x minus 1 all over 8 minus 1 all over 16. Gonna get negative 3 all over 16. And this is our final answer for our problem. That's how you get the equations of the tangent. Hopefully, maybe you've enjoyed our today's lesson. Have a nice day. I'll see you in my next video. Have a nice day.